Hello, this is Jack Jackson. In this video, we're going to talk about how to do some probability computations from the CDF graph, the cumulative density graph, cumulative density function graph of a continuous probability distribution. So recall that the y value on the CDF graph is the cumulative probability. That is a probability to the left of the input x value. So by that we mean the CDF of A is the probability that x is less than or equal to A, which is the same as the probability that x is less than A. So given a graph and an input value x equals A, we can simply find the corresponding y value on the CDF curve, take its y value, and that gives us the probability that x is less than or equal to A. On the other hand, if we go backwards from that, if we're given the cumulative probability, the probability that x is less than or equal to A, we know that, and we want to find A, then we do this backwards by we know the y value, and we just find the corresponding x. That type of question we call an inverse probability question. So the inverse probability question is going to be in the next video. This video is going to talk about the probability question. So we can find three kinds of probabilities that we often have to do. I'm going to call left probability, right probability, and middle probability. Left probability, or sometimes called left-tailed probability, is you look at the probability that x is less than A, which is the same thing as the probability that x is less than or equal to A, and that's just the CDF of A. In other words, it's just the y value on the CDF graph, the one that corresponds to x equals A. And we can also see that as a vertical distance from the x-axis up to the CDF curve. Now, if you're doing, so that's left probability. If you're doing a right probability to the right of A, that is the probability that x is greater than A, or also the probability that x is greater than or equal to A. That turns out to be 1 minus the CDF of A, 1 minus the probability that x is less than A. So that's 1 minus the CDF of A. So that's 1 minus a y value on the graph. This is also seen as a vertical distance. This time, instead of from the CDF graph down to the x-axis like we had on the left probability, this vertical distance goes from the CDF graph up to the line y equals 1. We can also do, oftentimes, we want a middle probability. Probability that looks like this. The probability that A is less than x, which is less than B. And in this case, it doesn't matter whether we put the or equal to's or not. Still the same probability. So this could be probability A less than or equal to x less than or equal to B. In the continuous case, the or equal to's don't really matter. So this turns out to be just the difference in two CDFs. It's the CDF of B minus the CDF of A. So it's the difference in two y values on the graph. And again, we can see this as a vertical distance. This is the vertical distance between the 2 points where x is A and x equals B, but it's that vertical distance, not the straight line distance, but just the vertical change between those 2 points. So let's actually put this in place now with a particular example. So in this example here, we see the graph of a CDF. First of all, let's just check out that it really is a CDF. What are the characteristics it needs? Well, it needs to start at 0, so it looks like it has an asymptote of 0 here, and on the left, and it increases up so that on the right it levels out at y equals 1, which is this dotted line right here. Yep, looks like it does that, increases in between, never goes down into the negatives. So it starts at 0 on the left, goes up to 1 on the right. So that's a good CDF. So let's take these three types of probabilities that we just talked about and compute them on the graph. Find the probability that x is less than 8, probability that x is greater than or equal to 4, and the probability that x is between 2 and 10. So let's start with the first one. Can you look at this graph and just tell me what the probability is that x is less than 8? Can you read it off the graph? Press pause and see if you can figure it out. Okay, did you come up with a number? Well, all you have to do, that is the same as the probability that x is less than or equal to 8, which is a CDF of 8. And so all you have to do is find 8 on the x-axis, go straight up to the point, and then go straight across here to read its y value. So this purple vertical distance, whether it's from this point here up to that, the length of that purple arrow, or this purple distance I have here, or I have it with this bracket, that distance is the probability. So it's a vertical distance here. And in this case, that's 0.8. So it's just the y value here. That's the point on the graph is 8, 0.8. Okay, so 80% is the probability we're looking for. So what does that mean? That means the probability that x is less than 8 or less than or equal to 8 is 80%, or 0.8. All right, how about the probability? I think the next one I wanted, the probability that x is greater than or equal to 4. So look at this graph. Let's see if you can show me how to do the probability that x is greater than or equal to 4. Well, a greater than probability is the probability to the right of 4. So we found 4 on the x-axis. We want the probability to the right over here. Okay? Well, up to this point, we have this probability, which is purple, from here up to here, which is 0.4, looks like. 0.45, excuse me. And then, but the total has to be 1. So what's left from, so to the left of 4, the probability is 0.45, so the right is 1 minus that, which is 0.55. We can see that as a vertical distance. It's a distance from this point up to the line y equals 1. So I could draw that right above this point, straight up to the line y equals 1, or I've drawn it over here, the corresponding places on the y-axis. And you can see that that distance is 0.55. I have it bracketed out here. So that vertical distance between these two y values of the y value of the CDF and the y value of 1, that vertical distance is a probability to the right. Now, if we want to find the probability between 2 and 10, that's just the CDF of 10 minus CDF of 2. So you find 10 on the graph. We go up here, find its CDF, which looks like 0.9. And then we find 2 on here, go up and find its CDF. It turns out to be about 0.27, at least at 2 decimal places. And we just subtract those two when we get 0.63. Now, this probability can also be seen as a vertical distance. You take the y value here, and you go up to the y value here. So I've drawn a horizontal dotted line here at the y value of the first point at 4. At x equals 2. And then going over here to x equals 10, find its height, the horizontal line there, and that was, what it was, 0.9. And so the difference between those two is this green length, that's the distance between this line and this one right here. That's this green distance here, and that is the probability we're looking for, which is 0.63. So notice, some way or another, you can always see the probability as some sort of vertical line, the length of a vertical line. It's the actual y value, which is the length of this purple vertical line from the axis up to the point when it's a left probability or less than probability. It's this orange distance from the point up to the line y equals 1 if it's a right probability. And of course, we would compute that by 1 minus the y value on the curve. So that's 1 minus CDF of 4 is the probability that x is greater than 4. And then if you want the probability between two numbers, it's the difference in two y values. So it's the CDF of the latter one minus the CDF of the first one. So CDF of 10 minus CDF of 2 in this case. And again, that gives us a vertical distance here, which I've pictured in green. All right, now it's time for you to do some. This is exactly the same thing. Okay, different graph, slightly different probabilities, but the same basic setup. So I'm going to give you a series. I've got a series of 5 exercises here, all based on this same graph, and we're going to work through them one at a time. Okay, so as usual, I'm going to ask you to pause and get an answer for each one of these before we go on to check your work. So we're going to see if you understand what's going on. It's very important that you work through these little exercises and kind of stay with me. Okay? All right. So first question, what is the probability that x equals 5? What is the probability that x equals 5? You should have an answer already because we know that what? We don't even have to look at the graph. We know that probability that x equals any specific value is always 0 for any continuous distribution. It has really nothing to do with the picture. It has to do with the fact that if you're talking about x equals 5, you have no width for your area under the PDF curve. Now you do have a value on the CDF curve, but it's not the probability that x equals 5, it's something else. Okay, but the probability that x equals a number is actually 0. So now see if you can figure out the probability that x is less than or equal to 5 and the probability that x is less than 5. See if you can do those two next. Press pause now. Now hopefully you worked those out and we were able to come up with this solution. You find 5 on the x-axis. This is a less than or equal to or left probability. That's just the y value. So you just take that 5, go up here and find the point on the graph, go across and see what the corresponding y is, and it looks like it's about 0.35. So it is the y value there, which is 0.35. So on the CDF, the y value is the cumulative probability. That is a left probability. It doesn't matter whether it's equal to or not, or just less than or equal to, or just less than. The equal to part doesn't matter because the probability that equals 5 is actually 0. And you can see as vertically as this vertical green distance here. Okay, so let's go ahead and do the next one. What's the probability that x is greater than 5? And then illustrate it as a vertical distance on this graph. Press pause now. Well, this time, visually, it is, you find 5 here, you find the point on the graph, but this time you go from there up to the line y equals 1. I put y equals 1 with this dark black line here. And so this is going from there up. Well, it looks like, which means it's 1 minus the distance down here, which is the probability, the CDF function. So the probability that x is greater than 5 is 1 minus the probability that x is less than or equal to 5, which is 1 minus the CDF of 5, which is 1 minus 0.35 or 0.65. So 0.65 is that probability, and that is the length of this green vertical line segment. All right, finally, let's finish it up. What's the probability that x is between 5 and 6? And illustrate that on the graph as well. Press pause now. Well, you find 5 and you go up there and find the y value where I've drawn a horizontal line. You find 6, go up there and draw a horizontal line. And what we're looking for is the difference in the two, the change, amount of change there, the vertical change. And so we're looking at the length of this green line segment right here, this vertical line segment. Which, since these go up by 0.05s, it looks like it's about 0.15. And of course we find it actually by just subtracting the two CDF values. So the probability that 5 is less than x, which is less than 6, is the probability that x is less than 6 minus the probability that x is less than 5. That is the CDF of 6 minus the CDF of 5. So you're just taking those two corresponding y values. When x is 6, the y is 0.5, and when x is 5, the y is 0.35. Subtract, you get 0.15. And again, this can be illustrated by a distance, the green vertical distance here. Come back in the next video and we'll talk about how to reverse this by finding some inverse probabilities.